let's continue our work on working on basic integration techniques. Again, our learning target is just to be able to evaluate a variety of integrals using all sorts of different techniques. Okay, if we look at this one right here, the first thing that I would be looking at doing is a u substitution. That won't work because I'll only end up getting 2x, and I actually have x plus 9. So one trick that we can use is something that's called separating the numerator. As long as there is a plus sign up in the numerator, we can go ahead and separate it. And the way that I'll separate it, I'm just going to turn it into two integrals. We'll have the integral of x over x squared plus 16 plus the integral of 9 over x squared plus 16. And then we'll just treat this as two totally separate problems. On this first one now, this is a good candidate for a u substitution. So if I let u equal x squared, du would equal 2x dx, and I'm just missing a 2. So I'll put a 1/2 on the outside, and so I'll end up having 1/2. My u is on the bottom, and everything else turns into du. So from here, we are going to, the integral of du over u is just natural log, so I'll have 1/2 natural log the absolute value of u, which is x squared plus 16. Okay, and then my next part on this one, since I wouldn't want to do a u substitution because I don't have an x up in the numerator, this would actually be an arctan problem. One thing that I would like to do is move the 9 out front though. So if I identify my parts for an arctan problem, my a would be 4, and my u would be x, and my du would, the derivative of x is just 1. So I have all my parts there. So arctan is, we've got our 9, it's always 1 over a, arctan u over a, so x over 4 plus c, and then that would be my answer. One change that I could do here on this one, if I have a 1/2 sitting here, I can always bump it up to the power. So an alternate way of writing this answer would be natural log square root of x plus 16 plus 9/4 arctan x over 4 plus c. Right. Another trick here, if we look at this, these problems are all very similar. If I look at this one, it's not an arctan problem, it's not, I can't do a u substitution because there's an extra x. So if the degree of the numerator is greater than or equal to the degree of the denominator, we will use long division. And we did do this last year. Let's just see if we remember it this year. So I'm going to take the number that's on the bottom, and that's going to go out in front, and then we're going to divide it into 2x squared. Okay, if you recall, we're going to think what would I have to multiply x squared by to get 2x squared, and that would be 2. And so now I'm going to take this 2 and multiply it by both parts. So I'm going to get 2x squared plus 32. And then from here we're going to subtract. So when I subtract, those cancel out. When I do this, this would be like a 0 minus 32, which is going to give me negative 32. So when I go to rewrite this problem, x squared plus 16 went into 2x squared 2 times, and then the remainder is 32 over x squared plus 16. And so what I'm going to do is be taking the integral of each part. The integral of 2 would just be 2x, and then the second one is set up nicely for an arctan problem again. I'm going to bump my 32 on the outside and just identify my parts once again. I know my a will be 4 once again. My u will be x, and the derivative of x is 1. So all of my parts are there. So this is an arctan, so I've got a 32 sitting out front over a, arctan u over a plus c. And the only thing I'd probably do to simplify this is actually find out what 32 divided by 4 is. So my final answer would be 2x, minus 8 arctan x over 4 plus c. All right. If I have an e down in the denominator, we kind of run into some problems because if I try to do a u substitution, I don't have an e to the x up top, so I would be stuck. So the trick that we are going to do is multiplying by e to the opposite sign. So if I have an e to the x, what I'm going to do is multiply by e to the negative x over e to the negative x. We're trying to turn this into a problem that we can actually do a u substitution for. So up top, 1 times e to the negative x is e to the negative x. And on the bottom, I'm going to distribute this to both terms. So I'm going to get 5 e to the negative x minus e to the x times e to the negative x would be e to the 0, which is just 1. Okay, and then from here, I now actually have turned this into a problem that I can perform a u substitution on. So we're going to let u equal 5 e to the negative x minus 1. And then the derivative of that would be negative 5 e to the negative x dx. And you'll notice I do have the e to the negative x up there. I'm just missing the negative 5, so I'll put a negative 1/5 on the outside. So if I go to rewrite this integral, I'm now going to have everything up top turns into du, and the denominator is just u. And then I know that the integral of du over u is natural log, so my answer is going to be negative 1/5 natural log of the absolute value of u plus c. And there we've got it. Great. Another trick that we can use are trig identities. One thing you notice, we do not have a formula for tangent squared. We do have a formula for secant squared, but not tangent squared. So we're going to make use of some trig identities. I'm just going to write down 3 that we will use most often. They're all Pythagorean identities. The sine squared x plus cosine squared x. Hopefully you remember that that equals 1. But we do have 2 more. Another one would be 1 plus tangent squared x is equal to secant squared x, and a third one is 1 plus cotangent squared x is equal to cosecant squared x. And so what we are going to do, since we're stuck, is I can use the identity tangent squared of 3x. I can use this one right here to rewrite it, because tangent squared x is equal to secant squared x minus 1. So if I rewrite this, I can rewrite this as secant squared 3x minus 1. And then I can actually take the integral of both parts separately. Okay, I do have an integral for secant squared, but I do have a 3x, so I'm going to do a u substitution. So I'm going to let u equal 3x. The derivative of 3x would be 3, so I'm missing a 3 on the inside, so I'll put a 1/3 on the outside. So that gives me 1/3 the integral of secant squared u, and I know that the integral of secant squared is tangent, so this one will be 1/3 tangent u. So that part is done, and then minus the integral of 1 is x, and then plus c, and I am all done. Alrighty, one more trick here when we're going to multiply by the conjugate. Notice we're kind of stuck here. I don't have a trig identity because there's no squares in the problem. I can't separate the numerator because the plus is not in the numerator. I can't do a u substitution. So one final trick that I can try is to multiply by the conjugate. The conjugate of 1 plus sine x is 1 minus sine x. So I'm going to multiply by the numerator and denominator by that. So in the numerator now, I'm going to have 1 minus sine x. And in the denominator, I'm going to have 1 minus sine squared x if I multiplied that out. Okay, next thing that we want to do is use trig identities, because I know that 1 minus sine squared x is equal to cosine squared x. So I'm going to have 1 minus sine x over cosine squared x. And then from here, kind of stuck, so I do notice a minus up top, which means I can separate the numerator. So if I separate the numerator, I'm going to have 1 over cosine squared x minus the integral of sine x over cosine squared x. All right, so now I'm going to deal with this first one. Kind of stuck here, but I do know I'm going to try to bring the 1 over cosine squared x up top. 1 over cosine squared is equal to secant squared, and now notice I do know the integral of secant squared. I know the integral of secant squared is equal to tangent squared x. Right? On this one, I do not have an integral for either of those, but I do know that I can do a u substitution. I'm going to let u equal cosine x, and then the derivative of cosine would be negative sine x. I notice I have the sign, I'm missing the negative, so that will just bump that to a positive. And then if I go to rewrite this, since I have a u in the denominator, but there's a 2 there, that would really be u to the negative 2, and then everything else in the problem turns to a du. So if I take the integral of u to the negative 2, remember we're going to increase the power by 1, so I'll get u to the negative 1, and then we'll put the reciprocal out front, so it will be minus. So now this is going to be tangent squared x minus 1 over u, and remember u was cosine x. And now I'm going to go one more step. We'll have tangent squared x minus 1 over cosine is actually equal to secant x plus c, and voila, I have the answer. And this is actually one of my favorite problems because we got to use so many tricks, and wasn't that fun? So hopefully now you can evaluate integrals using a variety of basic integration techniques.